Welcome back to P3. Today we're looking at Exponential Modeling, Unit 5.5. Now, Exponential Modeling, you can use e to the x to model situations such as population growth, where the rate of increase is proportional to the size of the population at any given moment. Equally, or similarly, you can use e to the negative x, and this would then model things like radioactive decay, where the rate of decrease is proportional to the number of atoms remaining. So both of these are very useful for modeling those types of problems where it's a rate. So here we have a modeling question where I've got the population of a country and it's modelled using a formula containing an exponential. So here we have it, p equals 20 plus 10e to the power t over 50. P is our population in thousands and t is time in years after the year 2000. So my first part now is to state the population in 2000. So this will happen when t equals 0. So we get p equals 20 plus 10e to the power 0. So e to the power 0 is 1. So this population is going to be 30. So we're looking at 30,000. Part B, predict the population in the year 2030. So t would equal 30 for this one. Therefore p would equal 20 plus 10e to the 30 over 50. And again, I just need to put this into my calculator and I get 38.221188. So this would be 38,221. Now, part C, we need to sketch P for the years 2000 all the way up to 2100. So this is between t equals 0 all the way up to t equals 100. So my bottom 0 there, this is going to be my t and my population will be my vertical axis. Now I already know that when t equals 0, my population is 30,000. So I want to first start by marking that 30,000 on the side. And then I get a nice exponential shaped curve like so. And what I need to think about is what happens at this 100 marker. And this 100 marker, if you put it into your calculator, will give you approximately 94,000. And here I have a rough sketch of what this graph would look like. So I've got it starting at the 30,000. At 100 it'll actually be 93,891. So you can see here what I've done is I've just put 94,000 there just above where I've drawn it to. And part D, would this model be valid to predict the population in the year 2500? Well, if I put t equals 500 into my calculator, I'm going to get 220,284, but obviously this is thousands, so add in an extra 3 zeros. Technically this would be a 5, but roughly speaking we're looking at over 220 million. Now, is this a valid figure? Well, 500 years is a long time to predict in the future. There are many things that could change that can affect this population growth. Anything from types of food, new technologies. There could be wars, there could be famines, there could be anything. So a whole host of things, host of factors are likely to affect the population growth when you're looking so far into the future. So for this one, you would say it's highly unlikely that this model would be valid, as by the year 2500 there are new factors that are likely to affect the population. Here I've just written it up for you, what I just said. Okay, now before I give you some questions to do, if you have found anything useful in this video so far or any of my other videos, please hit that subscribe button. Please also share with your friends, support my channel, and help me continue to make content that hopefully helps students studying the International A-Level. Thank you. So nice easy one, t equals 0, so theta equals 120 minus 100 e to the power 0. This is just the value 1. So we've got 120 minus 100, so we've got 20 degrees. Moving on to part B. Now in this one we're told that when the temperature is 70 degrees, the time is 40 seconds. So I need to substitute that in. So 70 equals 120 minus 100 e to the minus 40 lambda. So let's rearrange. 100 e to the minus 40 lambda equals 50. I will probably personally think of it in this way first, so that you can see what I'm doing. So I'm going to divide by the 50 there, and I'm also going to multiply by this one. So we've got e to the 40 lambda equals 2. Now I would take logs of both sides, log as in their natural log. This gives me 40 lambda ln e equals ln2. Natural log of e is just going to be 1, same log, same base. So we got 40 lambda equals ln 2. So ln equals, apologies, ln 2 as I said. So lambda equals ln 2 over 40. So part C, now you can see I've replaced my value of lambda in, and we've got 100 degrees and we want to find capital T. So 100 is equal 120 minus 100 e to the minus ln 2 over 40 capital T. So rearranging, I get 100 e to the minus ln 2 over 40 t equals 20. Now again, because this is a negative, I prefer to write this as e over the positive ln 2 over 40t, which will mean that then I end up with 5 equals e to the ln 2 over 40t. And taking logs of both sides, and then using the laws of logs to deal with my power, I get ln 5 equals ln 2 over 40t ln e, and this is just 1. So now I've got 40 ln 5 over ln 2 equals t. And since I don't need to write this as an exact answer, at this point I can put in my calculator. In my calculator, get 92.877 and so on. The question was nearest whole value, so we're looking at 93 seconds. So in this question, we've got the formula x equals de to the power minus 1/8 t, and we can see that a dose of 10 milligrams is given, and our time t is equal to 5 hours. So this is just a matter of substitution and using my calculator. And this gives me 5.353 correct to 3 decimal places, which is what the question wanted. Let's look at part B. So in this one now, a second dose of 10 milligrams is given after 5 hours. Show that the amount of the drug in the bloodstream 1 hour after the second dose is 13.549. So my formula is x equals de to the minus 1/8 t. Now if I think of the first dose was 10 milligrams, and this was given at 0 hours. So my first dose was 10 milligrams, and this was given at 0 hours on, straight away before I started counting. So by the time my second dose had happened, 5 hours had passed, which is here, and then we went an hour after the second dose, so 6 hours in total. So my first dose I want to think of in terms of 6 hours. So this is dose 1, and then when I think of dose 2, that's going to be a second 10 milligram dose, and this one's going to be for 1 hour. So in total I've got 2 doses to deal with. So I've got 10e to the minus 1/8 times 6 plus 10e to the minus 1/8 times 1. And it's this type of question where people tend to go wrong because they don't think of the first dose being on 0 hours, and they don't think it all the way through. You just need to break the question down. So using my calculator now, I can get the answer 13.549 milligrams to 3 decimal places. On to part C. Now, an alternative way of approaching this part of the question was again to look at what was happening at t equals 5 hours. So at t equals 5 hours, I'd have my 10e to the minus 5 over 8 plus 10e to the minus to the 0, which is just 10 plus 10e to the minus 5 over 8. So this is what's happening after 5 hours, and I get that the dose at this point is 15.353 to 3 decimal places. Then what I can do is use this as my value of d. So then I'm looking at when t is now an additional hour. So x equals 15.353 multiplied by e to the minus 1/8 t, where t is equal to 1. So it's e to the power minus 1/8. And putting this in my calculator, I get my 13.549 to 3 decimal places. Now, this method is one that actually makes it easier to do the part C of this question, the final part of this question. So without further ado, let's jump on to C. No more doses of the drug are given. At time t, hours after the second dose is given, the amount of drug in the bloodstream is 3 milligrams. Find the value of t. So again, think back to a formula. X equals dE to the minus 1/8 t. Now, a key part of this question that people forget about is its time t after the second dose. So that's not exactly like carrying on from where we were in part B, because that was 1 hour already after the second dose. And that's where a lot of people would go wrong on this question. So I'm going to approach it first with the second method that I use for part B. So then we have x equals 15.353. Remember, keep the full value in your calculator, times minus 1/8 capital T. I know that this x is actually 3 milligrams. So now I can divide by my 15.353, and that gives me approximately 0.195. Again, keep your full answer in your calculator. Now, taking logs of both sides, that ln 0.195 is going to be equal to minus 1/8 t, and then I need to multiply by minus 8, and then t is equal to 13.061, or t equals 13.1 seconds. Obviously it doesn't give me what it wants me to round it off to, so as long as I round it off to an appropriate value, I will be fine there. Now, if I didn't use this method, and I used the way I worked out part B initially, I get a much more difficult problem to solve, but one that is still solvable. So we have x equals 10e to the minus 5 plus t over 8 plus 10e to the minus 0 plus t over 8. This is because the second dose was taken at 5 hours, and then we're finding the value of capital T after that. So the first dose is 5 hours plus T, the second dose then will be 0 hours plus T. And another thing to be careful of is I'm going to put brackets in here because of that minus is outside both of those values. Now from here we know that x is 3. Next I would divide by 10, and that will give me e to the minus 5 plus t over 8 plus e to the minus t over 8. Next I need to split this up. It's adding, so that's going to be the same as multiplying. So I get e to the minus 5 over 8 multiplied by e to the minus t over 8. And then I can factorize out e to the minus t over 8, and that will give me inside my brackets e to the minus 5 over 8 plus 1. I now need to divide by this bracket. So 0.3 divided by e to the minus 5 over 8 plus 1 will give me 0.195, the 3 decimal places at this point. You should recognize this value. And taking logs of both sides, I will get this, and multiplying them by minus 8 will give me t equals 13.1. Now you should see here that this is a far more complicated method, and in this actual exam where this question took place, very few people picked up marks on this last part, part C. In fact, the most common mark was 1 mark, but where people had approached part B, the way I did it the second way, those people got full marks on this question. But where people approached it the way I did it the first way, those people tended to only pick up 1 mark at the end here. Hopefully you found this video useful. Again, if you did, please subscribe to the channel if you haven't done so already, and hit a like if you enjoyed this video.